everyone. Let's get right into it. So today we're going to talk about some amazing things you can do with computational design to help speed up your structural workflows. This webinar is geared towards structural engineers, and I'm going to kind of go and guide. First thing we're going to do is guide you through what is computational design, explain that to you, why you should use it, why is it important. From there, I'm going to pull you into some tools that is used for computational design so you get a familiarity with what that does. And then from there, we'll move into showing you some examples that we can use computational design for to help speed up our workflow and do some amazing stuff. And then after that, I'll give you a hint at some third-party programs that's already been created that's not bespoke to your company or what you would do, but kind of third-party that's kind of out there for the masses. All right. So first thing, we're going to talk about computational design and explain what is computational design. So I want you to take a thought and think about computational design. If you've heard of it before, you probably would say something along the lines of like automation. If you haven't heard of it before, you'll probably think computational, so something with computers, so like computers or like programming language or coding. And I would say that these are all correct. These are kind of, we at ASTI feel that computational design is this big bucket of things, but at its heart, at its core, it's a problem-solving methodology, meaning that it utilizes computational thinking that involves four basic steps. That means breaking down problems or decomposition, finding patterns, replicating those patterns, or pattern recognition. Also focusing on what's important and removing what's unnecessary or ignoring what's unnecessary, which is abstraction, and then kind of creating step-by-step algorithms to solve a problem, which is the fourth step. And you may also, when I ask you to think about what is computational design, you may think of like technologies such as like Dynamo, Grasshopper, Python, and Blender, or Bubble, actually another one too. All these different those I consider, or we consider, to be computational design technologies. So they allow you to utilize computational design to solve a particular problem for a particular program. Dynamo, you would say that's for Revit. Grasshopper would be something for, let's say, writing. So I explained to you what it was. Computational design was. It's a problem-solving methodology that uses computational design concepts in order to solve a problem. So why, as a structural engineer, do I need this? Why do I care? I'm going to kind of explain it in two ways. First, we're going to go back to what we're currently doing, and that's BIM. So BIM, which is essentially, if you're using Revit, you are essentially BIM. In the past, before Revit, we had kind of 2D lines, which is like AutoCAD, and then we had kind of 3D, which is kind of like a 3D Studio Max or SketchUp. In the 2D AutoCAD, you created two lines and that represented a wall. You created a line that represented a beam. With a 3D software like 3ds Max or SketchUp, you would create a three-dimensional object that represents and looks like our beam or looks like our wall. What BIM does is kind of combine just the visual aspects of it, but also put in a lot of data into it. So when I say BIM, that stands for Building Information Modeling, right? And what you see here is a beam, a W16 that I've drawn in the space of Revit. On the right-hand side, you'll see what's called type properties. Under that little type property window on the right-hand side, this is everything that pertains to this shape. So when you design a building, you use this information to design a shape. And every W16 by 26 will have this information for it, and it gives you a lot of information that you can use to design your beam, analyze your beam, and you can utilize that in your project. And this is all within inside Revit. So every time you draw a beam, you're getting this information attached to this particular beam. On the left-hand side, we will see that we have some other properties. These are what's called instance properties. So these are very customized to this particular beam, meaning things like the length. Every beam has a different length. Sometimes, not always, but sometimes they do have different lengths. And that will be recorded here. And you combine that information, you can start getting items. So, if you have the section modulus the length of the beam, the area of the beam, you start analyzing that beam for not just what it is and what it looks like, but also its strength and what you can do with it. Right? And what we're doing today, if you're using Revit and you're drawing a beam in your project, like a beam here, you are automatically putting in this data. And that data is what you can use to computational design to kind of help you speed up your workflows and do different items. The next thing I want to talk about is our structural engineering challenges. So today, as a structural engineer, you kind of see these three challenges. You probably see more, but these are kind of the big bucket ones. One is that projects are getting much more complex, and the client expectation of being high, especially with speed. Right? And we have labor shortages. The Great Resignation we talked about ever since the pandemic, and how everyone's looking for work. I haven't met a firm that isn't looking for someone to come that needs help to help build their firm out, kind of help them with their projects. They're so busy. And also team productivity. So trying to be more profitable, trying to get your projects out on time, within budget, with reduced errors is also a big challenge as structural engineers. Right? So when we start talking about the trends, or I would say the remedies to help this, the first one, which is the project complexity and client expectations, is increasing. BIM has helped us do that. The statistic at the bottom says that 80% of structural engineers will be using BIM for the majority of the projects by 2024. So that's like, I would say 80% of you are going to, by 2024, 80% of you who's watching this are probably going to be using BIM by 2024, essentially by that statistic. And BIM is Revit. So we're kind of already using that right now. And if you're using that, you're able to coordinate with your architects. You're also able to build and kind of minimize errors and clashes, which is all great and wonderful. The other two, which is the labor shortage, which you can utilize automations to help bridge that gap. So if you have if one person can do 150% more work, then that means that person could be more further utilized and can do more. That can help bridge that gap, because we can't just create more workers, right? So we can utilize automations to help that person be more efficient. The second one, again, is talking about efficiency. If we integrate our structural analysis tools with our design tools, our documentation tools, we are able to kind of help make us more efficient, make us be on time, because those times when you have to create a gravity model and a lateral model, and then you need to create another model just to document it in Revit, can be, if that's all one model, then you've been very efficient in that way. And with these two problems, automation and integration can be helped with computational design. So BIM or Revit is helping us there with that challenge. The next challenge is computational design. So that's where I would say that computational design is a big deal. It's a big deal because it's going to help bridge us that gap and help us overcome our challenges. Currently, right now, computational design is the next technology, meaning that BIM, as I stated before, that is 80% of the people 80% of structural firms will be using BIM. So you can no longer, 10 years ago, when you petitioned to get a project, you can go to your architect and say, hey, we use Revit, we use BIM, we're going to be able to coordinate with you, we can help reduce errors, we have better communication, and we can do that. I think now it's going to be, in this day and age, that's going to be the norm. They're going to expect you to do that. I always think back about cell phones. There was a time when you had a cell phone, you were considered that you had a lot of money, or you was just fancy that you had a cell phone. But now I just assume you have a cell phone, and I just assume like, hey, what's your cell phone number? Or let me contact you by cell, and the landline is kind of obsolete. That's going to be the same thing with Revit, is that people are just going to think you're using it. And the next step to kind of differentiate yourself from other firms is saying, I use computational design, so now not only can I coordinate with you and we can clash detect, but I also can reduce errors, and I can also work more efficiently because I'm using this technology, computational design. Next here is that we are already using that. We're already following it. So if you're using Revit currently, you already have the information there to be utilized. So there's no point not to use it. Last thing is that, which I mentioned before, was that these are the key components in our challenges today computational design can rectify or help with. Let's go to some computational design technologies. So there's a bunch of computational design technology out there. I'm gearing this more towards if you're using Revit. So I'm going to talk about Dynamo and PyRevit, which are computational design tools within Revit. But there's a bunch of others out there, like I saw Grasshopper and Rhino, which can be used with Revit. Blender and Blockies, all different tools you can use, visual programming tools as well. Talking about Dynamo, we're going to talk about Dynamo first. Dynamo was created back in 2013. It's a visual programming application, basically meaning that when you think of programming, some image in your head of like a big file with a whole bunch of text in it. Visual programming takes that text and bring it into blocks. So if you do a command, let's say move command, instead of you type and move, you bring a little node or a little box in there to help do that command for you. And that's really the big difference. It's a really great way to get started with programming. It kind of fits. I'm a visual person, so visual programming was a great start for me to kind of learn about it and see what I can do with programming. And that's what Dynamo done. Also, Dynamo is open source, meaning that anyone can contribute to it, as well as what's inside of it or how it was made is actually open to the public to kind of help create and build on it themselves. And Revit has a really robust community that helps further advance it and give nodes that's currently not out of the box from Dynamo. They've created and put it in there for you to further utilize it. Pros and cons. Pros and cons of Dynamo is it's open source, which I'm talking about. So open source, and it goes to the last one on that pros list is the robust community of contributors, meaning that when Dynamo came out, it had some limited functionality. And being that it was open source and people was able to add onto it, they added a lot of packages to help further out the what the capabilities of what Dynamo can do, which really helped this kind of move forward. Visual programming environment, which I kind of hinted at before as well, is that it's a very easy, good way to kind of get introduced into programming, and it's a little bit more to digest than just purely typing. You can access the Revit API, so even if there's a functionality that you want to do use it within Revit, you are able to, and it's not within inside Dynamo, you can create it yourself by using the API to kind of access those things. Now, two cons I would say is that it's an add-on application. So what that means is that it's an add-on. When you click on it in Revit, it will open up a new program that you didn't utilize. So it's a new program to learn, to kind of build on. And then at the same time, it's a little bit slower because you're accessing another program then to access Revit, such as other like add-ons that's built into Revit to do the same functionality can move a little quicker because it's running within Revit. The last thing is package distribution and updating. So packages is what was done by community to help further the functionality of Dynamo. And what I find that there's some challenges with distributing that throughout your company if everyone's using the same packages, because if you use a package node in your program, then everyone has to have the same one or to work. So there's some challenges there. That can overcome, and we can always help you with that. But it's something to be aware of, that package distribution is a challenge with Dynamo. So also, I'm sorry, went the wrong way. All right, so Dynamo, let's see, make sure I'm up. All right, so Dynamo, this is what the ribbon looks, where it's located in a ribbon. So if you currently have Revit, you have Dynamo automatically installed. After 2020, I believe, or 2019, after that, Dynamo has been automatically shipped with Revit and installed with Revit. And to locate that, you will go to your Manage tab, and then you would go to Visual Programming Panel and click Dynamo. On the right of that, you have your Dynamo player. So Dynamo will give you your typical interface and show you what Dynamo, and I'll show you a picture of what that looks like in a second. And then the player will allow you to run these scripts without having to open up full Dynamo. That's what that's for. So Dynamo, this is the user interface, and as you can see, these are all nodes. These are all nodes. What the nodes do is they will do one functionality. So this particular node will create a circle. You give it a center point and you give it a radius, it will create a circle. So that's how you see that's the center point that was given to it. And then you give it a radius of 3.5, which is what created the circle. And then from that, the center point, you need a point. So then you go over to this point. And what this block is doing is creating a point. It needs a number, tell you where this location is, which is at 3.5. And then with that information, it creates a point. That point goes into the circle to find your center point, and then you give it a radius to create your circle. So that's how visual programming kind of looks. And then on the left-hand side, you see this library. Now, this library is only touching the surface of what's in here. So many, many more tools. And if you add packages, it even multiplies that amount of tools there that you can use to function. All right, next is PyRevit. PyRevit was created by Ensign, I believe in 2016. I think it was out for first release. It's an application development environment using Python. And that's just a fancy term of saying you're able to create your own tools, essentially. Kind of dump it down a little bit. And it's interesting because Python is a translated language or dynamic language, which means that you're able to create scripts and test them fairly quickly. And that's kind of why I didn't use Python in the first place when creating it. And this, as well as Dynamo, is open source. It's been created by this. It's been created. It's freeware. You can get it online, but by downloading and installing it. And then people have contributed to that. So it's not just Eisen. If you go to the GitHub, there's a couple other contributors to it as well. Pros and cons. Pros in this case is open source. People can contribute to it. And it's customizable, so you can contribute to it to yourself and do customize and change it as much as you want. It accesses the API just like Revit using Python. The difference, the environment's a little different. This is not nodes. This is purely what you would think when someone says a coder or a programmer and what they do and how they create code. This image is kind of what you would see with Python, just a block of text inside of a document program. Rapid application prototyping environment, and that's what I'm referring to because the Python is quick to test. That's what it's saying, that it's very quick for you to test the application or the tool that you're creating and get feedback on it because of the type of language Python is. It's deployable. This is one of the great features of it that really differs it from Dynamo, is that it's very easily deployable. You can put a folder in a location on your server and everyone can access it, and it's kind of real live because it's Python. So if you have a mistake, or not a mistake, I would say there's an error within the code or someone wants to make some changes, you can literally, and I have done this, is go in, change it, and then say, okay, I changed it, saved it. You can go ahead and that person uses it within seconds after you updated it with the new code, which is great. It also has embedded data tracking. So these are the data and numbers, and it's already embedded. There needs to be some server-side information that you need to do, but it's all within the code, and it's kind of easy to log it even with JavaScript. So it's great. The only con I see, because I think PyRevit generally overall is a great program, if you're not really interested in computational design, or if you are, but you want to get a feel for it, I think any firm, anybody can really use PyRevit within their firm to kind of help do stuff because it has a robust amount of tools already added to it. And I'll show you that in the next slide. But the one con for it, I would say, is that it's a community product, meaning that if Eisen has a life change and he's no longer able to work on this, then it dies. While Dynamo is backed by Autodesk, and Autodesk is kind of building it up. So the chances of that dying because one of the developers had a life change is very slim to none. While this one can be because Eisen kind of created it. And as we move forward, you will see that may kind of change if you're able to access it or use it in future Revit versions. So the interface within PyRevit interface within Revit is it has its own tab. So it'll be a PyRevit tab. It also has a couple different tabs, a couple of add-ons. I'm showing you here the main PyRevit add-on. So the first two images is the main one that has a big set of tools. One of my favorites is the Sheets and Revit revision tools that you see inside of there, as well as there's a family importer tool that's really nice. And the bottom image is the structure tools that they have. Excuse me. I find some good uses for the total length and total area of items, but some of them is pretty good. But again, these are all completely customized. You can change them up, change the sizes, you can really customize this however you want, and also have your own tab. So if your company is Company X, you can have a Company X tool which you combine the tools that you want or your own custom tools in there, which makes it very flexible. This is kind of user interface. So outside of Dynamo, this is your traditional kind of text-based programming using Python to kind of create your code. As an example, on the right, you will see some folders, and this is the folder structure. So everything in the folder structure is very, very straightforward. So you have a tab is a folder, so you see this pyrevit.tab. And inside that tab, you have panels. So let's say the draw panel. You have that. Inside that folder in the draw set panel, you have individual push buttons. And then inside of each one of those individual folders, you will have what's called your script. So you have a script. The main ones outside of these XMLs is this script py and this icon png. The icon will show up on your ribbon, and then the script will show you what's going to execute when you push the button. So that is the icon right there for the sheets. So I'm going back one. This is the icon for the sheets, and then when you hit that, the script.py in that folder will run for you. And that's what you can update when you want to change it, or there's a bug or something. You just update that, and then when the next person hits it, they're going to retrieve the newest and freshest version of the PY. All right, so next we can go into some examples. I gave you a good bit of background about computational design, what it is to us at ASCII, it's a problem-solving methodology. Give you some technology that we can use to create and build some tools. Now it's time for me to show you some tools that I've built and I've used in the past to help speed up workflows. When you think about these, I really want you to focus not on the individual tool, but on the overall what it can do. So an example would be if you have someone that types books, right? You may say to yourself, I don't need someone to type books for me. But what I want you to get out of that person can type. So you may not need type books, but you need someone to type your emails. You need someone to type some information on Excel sheets. You may need someone to type some tutorials. So the idea is that don't focus on exactly what it's doing, and that object will focus on what it can do in that big bucket. And I'll kind of help you guide through that as we talk about it. But these are things you can utilize within your firm to help you. First thing, I'm going to start out, I have kind of 3 levels. It's the starter, the intermediate, and the advanced. The starter, we're going to talk about kind of the out-of-the-box Revit. Trying to utilize tools within Revit. So if you're just getting started and you don't know a whole lot about Revit, this is a good primer, just utilizing and stretching out the normal functionality within Revit to speed up your workflows or kind of help you out. All right, so the tools that you use here is Revit stuff such as schedules, filters, making custom parameters, and then doing some more advanced or family manipulation to kind of access this. Excuse me. All right, and what this unlocks, and that unlock means is that what you can now do with this. All right, so as you push forward and more advanced, you can still do this stuff, but you're just using it in a different method. So what this really unlocks is that quality control. You can kind of go in and do some good quality control and kind of check your members and check your designs. And also you can do material lists within the building. First thing I'm going to show you, a little bit of it I'm going to show you in a second after I explain it, is the still tonnage schedule. So if you ever had a project and when they get priced, it comes back with a whole bunch of steel and it seems really high. If you want to verify that based on what you already drew. So this is stuff that you already drew just to get this project out. You need to draw what you see in the screen. You need to draw the members and it's all there. Now we can start utilizing that stuff that we've already drawn, kind of create a schedule that tells the tonnage to see what's actually in this project. Now, obviously, if you don't build any miscellaneous steel, that won't be added, but this gives you a ballpark. I wouldn't say this will be exactly exact, but it gives you a good ballpark what it is. So I'm going to go and run this script for you. First thing I'm doing is I'm just showing you around the project so you can see that's all filled out with steel. All right, next we're going to go over to the schedule called the steel tonnage. In the schedule, you'll see the member, the length, its weight, and this is, all this information is within inside the member already when you built it. You just got to put it in the schedule and create your schedule. And you also have to create that last bar there that I'm showing you now how I created that is to kind of calculate the weight. And we want it in tons, so that's in pounds per foot. So we just change the formatting. If you look at the formatting, then we go to conditional format. Oops, sorry, wrong one. Conditional formatting, we just change that to 4. So even though it's pounds, Revit will automatically change it to tonnage for you. Right? And we just ask Revit to give us a total, and at the bottom you'll see that it's a little bit more than 2,000 tons. Right? So the contract comes back when it's saying 8,000 tons, but it's still, then you know there's something off because that's quite different. You know, they come back with 2,200. It's like, that could be the installation, the miscellaneous still, but it gives you a good ballpark of what's going on in the building. Next one is going to span the depth ratio. So there's some rules that you have in span the depth ratio, like if it's and this is a good one so you can check your members. So after your designer kind of does their thing, you want to make sure everything got transcribed into Revit correctly. You can utilize a tool such as this to kind of just go back and just check and gut check what's there. Because what we do currently is we'll go in and check a few members because of time. But here, this is going to check all the members for you and flag those that has a problem. So here, let me show you this video. So checking the model, I have a bunch of beams. Again, you're already creating this stuff already. All right, I'm gonna click on one beam, and we did add a new parameter called the span and depth ratio. And as you click a couple of them, you'll see that this was calculated. It's really easy to do that. I would say it's quicker to use a computational design tool to push that in there for you. It's a little bit more harder to do it out of the box, but it's still great. Let me pause that, kind of stepped out of it. So what happened is, I'm gonna go back. So what happened here was I had that span to depth ratio and in that parameter. Then I created a filter here, and the filter we'll look at that parameter, right? If that parameter meets this criteria, it will make that member red, right? So that's what you're seeing me turn on. So when I say enable filter, that's me turning it on so I can see the red members in this project. All right. So now when you see here is that now you see these members red. So now that gives me a hint that I've just checked all the members essentially that span the depth ratio. And these members, we may need to go back and check to make sure they were subscribed correctly from the analytical model, or they may need to be updated because they don't meet that criteria that we have. In the program, I kind of show you, I think I used 13, but that's really up to you, whatever you feel comfortable with that you want to see and get flagged. But that's really out there. This is not using any computational design tools. This is just thinking about the tools that you already have in Revit and using them in different ways to kind of help you and speed up your workflows. The next one is intermediate. The intermediate is now we're starting to use Revit, and then we're using these more so out of the box tools such as Dynamo and PyRevit. So this is going to unlock. So the tools that you'll be using is Dynamo, PyRevit, like I stated, and also you could use Rhino and Grasshopper as well in that mix, because it is a tool out there. I don't see it as much. I see mostly Dynamo and PyRevit, but it's a tool that you can use. What this unlocks now, you can still get quality control, but now you can do automations, and you also can transfer data from outside sources. Let me show you one of those. So this, excuse me. So this script is the automated detail placement. So, and this is, when I look at this, I say the big bucket here is that you can automate placing a detail or some item into Revit. This particular project is we have a PT slab. We need to place a family that represents our top reinforcement for our columns. Instead of someone going in individually and placing those, I'm going to use a script to kind of do that for me and help me out. Now, I'll say at the time that I did this, I was in industry and I had time to create the script, but it took a little bit more work for me to create the script to do it completely automatic. So even for you, if you don't have the time to create completely automatic, you can use something that I've done here to kind of help still bridge that gap and make you a little bit more efficient without spending all your time trying to create a tool. So it was a little difficult to create it to be completely customizable, which I've created since then. But what I've done here as a step is to first create. First thing it does is it places all the top reinforcing on them, but it doesn't differentiate between if it's a corner or edge column, right? So then now what I'm doing, what you're seeing now, just what happened, is that I'm now going using some hotkeys on my mouse or some keyboard shortcuts on my mouse to kind of change those quickly to the edge or corner, right? So that's what I'm doing here. And those are all, if we go back, I'm gonna go back a little bit till we can see that tool. So we see this tool bar here. This is putting that center, the interior column reinforcement on all of them. And then I'm using these two buttons by the use of keyboard strokes to rotate the object or change it to an edge or a corner reinforcement. All right, big bucket. We are placing items within Revit based on, let's say in this case, companies. All right, the next one is foundation tag automation. So here we have these tags. This particular customer, they have all the information. They want one tag for everything. So if you was to tag like your pier, your base plate, and your columns are all different tags based on that object. What they wanted to do is have one tag, which is from the foundation, kind of have all that information. So you would literally have to type everything in if you did this without automation, but now this is automatic. It's going to take all that information from the columns, the base plates, and the pier that's there and populate out these foundation tags, right? So the foundation tag automatically tells you the elevation of it, and then tell you the type of foundation it is. But now what information you need is that what column is here, what base plate that column is using, and also if there's a pier, what that is, right? And that's what this is going to demonstrate. Right? So I'm just showing you that information. That information is put in as a text into that column to be read by the tag. So I'm going to run that script, and I'm using Dynamo Player here because we just need to run it. We don't need to have the full one. This is the explanation of what it's going to do. You hit it, and within a couple seconds, all those columns. And on here, you only see, I would say 12 columns or 12 foundations. More realistic, you'll see probably in like 50 or more on the project. So it really saves a lot of time like that. Big bucket is now you're taking the big bucket or big scope. I want you to think you may not need this to do this for you, but what you can take from it is that I can get Dynamo to take some information that's already in the model and place it somewhere else for me to utilize in a different way. All right, transfer designs to Revit. So in this project, we use real world is we use ETABS to design our concrete building, and our concrete building for both gravity and lateral. And once that's done, we put that information or the loads into Revit into Excel to design our foundations. So this is me making a mock-up. This is not the real project. I'm getting those loads in from ETABS, putting in our load combinations, and then designing my foundation. And now that I've done all this work to design my foundation, now what I would typically do is say, okay, mark 1 or location C1 is F6. I would go in and click on that object and change it to 6.1. Now I'm going to utilize Dynamo to automatically change those for us. All right. I'm going to show you that. So first, I'm going to just show you all the information that we have there. And then I'm going to run in and go through. Now you just see that they're all the same size foundation. The script is not very complicated. This is why it's intermediate. And then we're going to push that run button. And then now when we go back into that project, we'll see that now we have all different sizes. So that just pushed it and speeded up our workflow there. Big bucket of this is that I can take Excel file information and modify my model with it. So if we had shear walls and you said, hey, I want to put information or change some properties about the shear walls, you can design all that information in your typical spreadsheet. And then once you're all done and ready to send that over to Revit, you can utilize a program like this instead of typing. But that does save us a lot of errors. So, when you have 200 foundations and you try to change those, there's bound to be one. You have 1,000 beams, there's bound to be one that you make a mistake on. And if it helps save that time, not only saves time, but also stop those errors from happening. Last one is advanced. So these are more advanced tools. And I would say that if you're comfortable and your team is comfortable with using the starter and the intermediate tools, then advanced tools are really great because these take a lot more time to develop, as well as it takes a bit of coordination between the team to do these and use these right. So these are what I would say that once I get comfortable and start using it for some time, advanced would be the next thing to go because you can really do a lot of good things here. So the tools here, now I would say these tools are Revit, is using Revit, a computational design technology with some advanced tools, with some additional add-ons to do that. So Boham is a tool to help integrate different programs together that you can look at. Simplex, also another tool that helps combine Dynamo inside of using ETABS and RAM structural system. You have Rhino Grasshopper that can help do some very advanced, and Rhino and Grasshopper. And we have Rhino inside Revit, which is also a program to help take stuff that was built from Grasshopper and bring it over to Revit for you, right? And what this unlocks and allows you to do is now do some really complex modeling because we're utilizing, first we're using our Revit for some complex modeling. Rhino for complex modeling. Interoperability, that means you can now talk to your analysis software and bring them into Revit and back and forth, as well as some advanced operations that you can do. First thing I'm going to show you, the clash detection. This was done. We have our structural members in here. We want to make sure that they're not hitting any of our mechanical equipment because we had a change. So let's say you had a change. We need to change those trusses, but the mechanical engineer already did their work, and we want to minimize that as much as possible so you can run this. What this does is it will create, every time there's a crash, it will create an indicator, which is essentially a ball that has a color, that's a color based on what it is. And it allows you to indicate it and see it in real time. Now, this can be done as a program like Navisworks, but if you don't have it or you don't want to learn a new program, you can utilize Computational Design to help notify where these crashes are, and you can help fix those right up front. And that's one of the key, when you say this is one of the key things with Revit, is that we can coordinate and crash detect, but the by hand is that everyone got to go look at every member and look at what's there. Here, you can just run the script, which is fairly quick, and see what's there, make your adjustments, and you just speed up your workflows, just making sure that you're not clashing into anything. All right, so this is a more complex script. That's why it's in the advanced. So it's quite lengthy, but then you get all that information there. You see all those red indicators are all there to let you know that these are all spots where things are clashing and hitting to each other. All right. Next, we have some advanced modeling. This one I don't have a video. I'm just showing you. This is not something I've done. This is actually what Marcello depicted in PAS, I think, Oildesk University. But it shows you some advanced modeling. So in this case, the architect really wanted to make it a good challenge for the structural engineer by making this like kind of curving roof here. And then you could utilize Dynamo to kind of help build that for you, so you're not putting in each individual beam by yourself, which takes all the time. Robot to Revit. I'm not going to play this one. I just want to make sure we're on time, but this is basically, I'm going to play it while we're talking, so let me stop in it. So what this is taking, we have this robot model. When this could be, and for you to think about it, this could be RAM, this could be CSI, this could be Tekla, and you want to bring it right into Revit. Utilize this is used like Boham to do it, but you can utilize Dynamo to do that, or Revit or whatever to do that. And I'm going to skip ahead. You just see with a hit of the button and a little bit of movie magic, takes a couple of minutes, you can get that model back into Revit for you, so you can start doing that. All right, so now I'm going to talk about kind of the last topic we're going to talk about today is third-party tools. So if you're saying, hey, this is great, I think I can utilize computational design, but I'm a small firm, or I don't want to do it, can I just buy the tools from someone else to do it? And I say yes, there are tools you can buy, or there's some free tools out there that you can use to kind of do some of this kind of workflow stuff for you. And I put a list of these that I've seen. I haven't used all of them, but they've seen and they've worked and get some good reviews for them. But the thing to note about these is the tools that I showed you was bespoke to that firm and how they work. All right. So in the case of point, that foundation tool, the piers were foundation slabs that made the pier. If you use columns and you use that same script for your piers, if you use columns for your piers and you use that same script, it won't work the same way because it's based on your firm and how you use it. These are made to fit out to the masses. So as you talk to anyone who uses these, that they have their quirks and they have some things that you got to notify and don't work really well. They don't always work really well because your firm has very specific ways how they do things. And that's where these kind of falters, because they're made for the masses for multiple people. It covers a lot and it does a lot, but for your firm particularly, it may not do exactly what you want. And that's why custom doing it is a great thing to do. I am going to talk about two of these tools. That's Intercalc for Revit and also the GRAITEC Power Pack. Intercalc for Revit, I think if you use Intercalc before, I've used it in my past. It was great. And it's just nice that I can now utilize this inside of my project. So I'm just show you a video. I'm not going to talk about the other slides. The slides are, we can give you the slides if you want to look at those or you want to look it up. But I do want to show you that you can have your model into Revit. You have your model in Revit, and now you want to start designing beams. You go and open up the interface for you right out of Revit. Open up the interface. You can change, add loads, do what you need to do, design a beam, and then update it, which is amazing. I'm not going to show the whole thing. We're kind of running a long time. So, but I do want you to see this and hint that there's objects out here. You just got to get used to them and do things. And this is one of the ones that I really like. So you're using this, they're showing you that they created a beam and they designed that beam, and now the reaction is on another beam. Now we got to design that for that reaction, which is done. You see this is all pretty streamless. You just jumping in and out of your model, going in Revit, going back into Intercalc to save these, and they're all connected. All right, now let's get past that. So next I want to talk about the GRAITEC Power Pack. That's something that GRAITEC has, and this is this tool has a massive amount of useful tools in here. It kind of combines, like if you're already using tools in your current workflows, it's usually using one or two tools from this package, one or two tools from this package, one or two from here. And GRAITEC really has combined a lot of this stuff, plus some others in here to really help your workflows. Great tools like the Excel tool, where you can export out some model information, change it using the Excel unit interface and bring it back in to update it. It's really great. I find that this dimensioning tool, which is what I'm going to show you, is really good too to save some time when you're dimensioning all those grids and all those columns and things like that. And we also kind of like Intercalc is that you can design some beams and some members within the program within this on your toolbar, and this is what happens in a concrete package, which you can do on your project. So I would say Intercalc for Revit does steel and wood, while this GRAITEC Power Pack does concrete and does it really well. Another big thing is the concrete reinforcement. Right now, we're not. Right now, I've never put in reinforcement in my plans, but I think as we move forward, I've also went to conferences where they're talking about how our 3D model is going to be a submittal at some point in time. So it'd be good that we're able to do this stuff and kind of utilize these softwares to kind of help us be a little bit more efficient and kind of get our models up to snuff. I'm going to show you that GRAITEC Power Pack, that one. Want to make dimensioning. Now I'm going to not show sound because you don't really need that. All right, I'm going to show you quickly. I'm going to skip through it a little bit, but I really think this is a really powerful tool that you can get to help your firm out and give you kind of used to using computational design tools before you start creating your own as well. So you just see that you got some rules to configure your auto dimensioning, and then once you set up those rules, you can kind of click on some items, and it will start dimensioning. Now this is more of an architectural tool, but it can be, the same premise can be done to columns or to grids. This is a chance where you see a bunch of columns and you can go and utilize the tool to help dimension all your columns for you. All right. Great. All right. So that kind of comes to the end of our webinar, what I showed you today. Today we talked about computational design, what it is, why it's important, and I explained to you how it's the next big thing. It's going to help save you time and help kind of break away some of your current challenges in your firm. Then I told you some tools that it's used for creating computational design. I like to call them computational design technologies, which was PyRevit and Dynamo. After that, I gave you some examples how I use both PyRevit and Dynamo to kind of help speed up some workflows and do some. Remember, when you think about these, think about big buckets, not just what that individual tool does. And then after that, I showed you some third parties and where if you wanted to get it from somewhere else, just to kind of start pushing it, start trying out, tasting it before you start getting your own custom thing, where you can go and access it. And I hinted at the Intercalc for Revit and the Power Pack, which are great tools that you can utilize. And then I'm gonna give you one bonus. I told you that I'll give you one bonus. Like if you watch this webinar today and say, hey, I think I really need computational design, how do I get started? I would say identify your pug. This is not my term that I created. This is a term that came from my past, and it kind of stuck with me. So PUG stands for Power User Group. And to identify that person, meaning the group that kind of stretches out Revit, uses a lot, the people that you go to or the person that you go to for any Revit questions is probably your PUG. And go to that person and try to introduce him to computational design, what you can do to it. And if you empower that person to do that and advance that to help improve your workflows, you can get far. I say all you really need to do is 1 and 2, because if you empower that PUG to do it and kind of work with it and explore this option, you'll get a lot of it. But if you need some additional steps, I say you just need to really start learning. Get that PUG to that PUG person to start learning, watch some stuff, try some things out, and then create. All right. Thank you very much, everyone, for listening to me today. Do anyone have any questions?